All right. So we've been talking about functions as we've been going, but we haven't talked about functions or trig functions other than sines and cosines. And so let's start taking a look at some of these different functions. So we know, or we memorized, unfortunately, and perhaps you will prove this later to yourself, but we know that the derivative of sine is cosine, and the derivative of cosine is a negative sine. Okay, so with only that knowledge we are armed with, we are going to show what the derivative of tangent is. And then we're also going to take a look at secant. And we're going to take a look at cotangent and cosecant. Okay, so we've got 4 other functions that we're going to take a look at. So we've got sine, cosine, and their reciprocals, secant and cosecant. And then we've got tangent and cotangent. Now, the beautiful thing is all we need are the product rules and the quotient rules. And really only the quotient rules. However, let's start off with derivative of tangent. The derivative of tangent, and we can rewrite tangent, is equal to the derivative with respect to x of sine of x over cosine of x. Okay, so let's go ahead and take a look at this. Derivative of a quotient, and so we identify f of x is equal to sine of x. Its derivative is cosine of x. G of x is the bottom, which is cosine of x. The derivative of cosine is a negative sine. And we just simply run the quotient rule. Now, I'm not going to write it down this time because I have it memorized, but I would encourage you to write it down until you have it absolutely known to the best of your ability. You can just throw it out there. So I know that it's the derivative of the top, which is cosine of x, times the bottom, sine of x, minus the derivative of the bottom, which is a negative sine of x, times the top, which is sine of x. And already I can tell that I've made a mistake because the derivative of the top is cosine and the bottom is not sine. It is cosine. Cosine. Okay. All over the bottom, which is cosine of x squared. Cosine of squared of x. All right, so let's go ahead and rewrite this just a little bit. We have cosine squared x plus sine squared x over cosine squared x. There are 2 different ways you can go about this. Okay, I'm going to go both ways here. Way number 1, cosine squared plus sine squared equals 1. Pythagorean's identity for trig functions. All right, and so these are x's also in here. So now wherever we see that, we can put a 1. So we have 1 over cosine. So the derivative of tangent turned out to be 1 over cosine squared of x, but 1 over cosine is just secant squared of x. The second way to doing it, the second way of doing it is to split them up. So you have cosine squared x plus over cosine squared x plus sine squared x over cosine squared x. All right, this is 1, and so this equals 1 plus tangent squared x. So the derivative of tangent x is 1 plus tangent squared x. Okay, I guess if you really wanted to, you could say, well, the derivative of tangent equals that, derivative of tangent equals that, which means those 2 things are equal. Yes, they are, in fact. 1 plus tangent squared x is equal to secant x, or secant squared x. Okay, that's another one of those Pythagorean identities. I expect my students to know only those, and we talk about deriving the rest of them. All right, let's take a look at the next one on our list, which is secant. What is the derivative of secant? And so we're taking the derivative of secant of x, which is really taking the derivative of 1 over cosine of x. And so if we identify f of x is equal to 1, f prime of x is equal to 0, g of x, which is the bottom, is cosine. G prime of x is equal to negative sine. And so now I can run with my quotient rule. The derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. Okay, so the derivative of secant of x is equal to this. 0 cancels out, and so that whole thing goes away. A negative and a negative is a positive, so we have sine of x over cosine squared x, which is the same as sine x over cosine x times 1 over cosine x. And as we all know, this is tangent. This is secant. Apparently my secants start with C's now. So the derivative with respect to x of secant x is equal to secant tangent x. All right. Notice you can memorize these if you want, but why? Now we take a look at cotangent. Now before you get really antsy and say, oh, well, it's just the inverse, so if I just flip it, then I'm done. Be very, very, very careful doing that. Remember, you can't just necessarily flip a function and have it be the same. Excuse me, have it be the same. So let's take a look at the derivative with respect to x of cotangent of x. Okay, well, that's going to be the derivative with respect to x of cosine x over sine of x. So I'm going to identify my f of x is equal to cosine x. My f prime of x is equal to negative sine of x. My bottom, g of x, is equal to sine of x. My derivative of g is the cosine of x. So now my derivative of cotangent x is equal to the derivative of the top, which is negative sine x, times the bottom, which is sine x, minus the derivative of the bottom, which is cosine x, times the top, which is cosine x, all over the bottom squared, which is sine squared x. Okay, so now this is equal to negative 1 times the top. Now I pulled the negative out of the top, and so this is going to be sine squared x plus cosine squared x all over sine squared x. And now we have the same thing that we had up in the tangent, where we have two different ways to go about this. All right, so let me take way one. Number one, negative 1 times sine squared x plus cosine squared x all over sine squared x. Pythagorean's theorem says sine squared x plus cosine squared x is equal to 1. So that means that the derivative with respect to x of cotangent of x is equal to negative 1 times 1 over sine squared of x, which is the negative of cosecant squared x. So the derivative with respect to x of cotangent x is equal to negative cosecant x, or squared x. Now the derivative of tangent turned out to be secant squared. And so cotangent goes to cosecant, and it takes a negative sign with it. All right. The second way of doing it is -1 times the quantity sine squared x plus cosine squared x all over sine squared x. Is to split the fraction, so you have -1 times sine squared x over sine squared x plus -1 times cosine squared x over sine squared x. And so you end up having, this is -1 minus cotangent squared of x. Okay. So now that we have that established, this is also you can factor out a -1, so -1 times 1 plus cotangent squared x. And this, if you do the Pythagorean identity again, this is actually cosecant squared of x. And so you have -1 times cosecant squared of x is equal to the derivative with respect to x of cotangent of x. And so either way, it doesn't matter which way, you end up with negative cosecant squared. All right, for the final one, we are looking at the derivative of cosecant. Remember, you don't have to view all these videos if you understand what's going on. It's just a matter of, I thought I'd explain where these things come from. That is not magic. The derivative with respect to x, then, this is 1 over sine. And so this is a good practice, though, for learning your quotient rule, because it puts into quite a bit of practice of, hey, what is the top function? What is the bottom function? Top function in this case is 1. Its derivative is 0. The bottom function is sine. Its derivative is cosine. And so the derivative with respect to x of cosecant of x is equal to the derivative of the top, which is 0, times the bottom, which is sine, minus the derivative of the bottom, which is cosine, times the top, which is 1, all over the bottom squared, which is sine squared x. Well, that's the same. That goes away. This just is 0. And so I have negative cosine of x over sine squared x, which is really negative cosine x over sine x times 1 over sine x. Okay. Cosine over sine is cotangent. So this is cotangent, or negative cotangent x. 1 over sine is cosecant x. So the derivative with respect to x of cosecant x is negative cotangent cosecant. The derivative of secant turned out to be tangent secant or secant tangent. And so you flip the cos. So if you're looking for the derivative of secant, it's secant tangent. If you're looking for the derivative of cosecant, it's cosecant cotangent with a negative sign. And so those are some memorizing tricks. All right, so in this video, we went ahead and we derived all of these rules. Again, I don't expect my students to know how to do, or to know these rules. I expect them to be able to do it, to understand what the definition of tangent, secant, cotangent, cosecant are, and to apply the quotient rule to derive what they need. Understanding is much more powerful than memorization.